My name's Adam, and this is Cole, and this is why our fixture design is the best for this project. The task at hand is to design, manufacture, and test a CNC milling fixture that will be implemented onto an FMS pallet system on a Haas EC400 horizontal CNC mill. The fixture needs to hold the OP1 keychain blank and allow the CNC machine to perform the OP2 milling procedure. The fixture must be designed, built, and tested utilizing Mike 6 tooling plate, Mighty Bite fixture supplies, SolidWorks, HSM Works, and the Haas CNC VF2 Super Speed mill. The overall goal is to multiply this fixture and scale up mass production of many keychain parts on multiple tombstones in the pallet pool of the horizontal mill. Design constraints and criteria for this fixture design consists of a few main things. If achieved at a minimum and ideally exceeded, the design of the fixture should be successful. This includes producing 2 finished keychain parts and the clamping forces of the fixture withstanding the tooling forces with a minimum safety factor of 2.0.
To meet the design constraints mentioned by Adam, we located our part face down on the tooling plate, butted up against a 2-inch Mighty Bite locating rail, and lastly pressed to a 0.375-inch dowel pin. The part is securely clamped against the B datum with 2 800-pound Mighty Bite clamps, which are centered on the individual keychains. A WCS bore is in the top left to be conveniently probed, and a 0.25-inch pokey yoke dowel pin was added to prevent improper loading. The last features present are a square indicating band, 2 T-bracket bolt holes with excessive counterbore relief to mount to the fixture, some cosmetic engraving, and chamfering for comfort. To ensure our keychain parts would not throw during milling, we found that we needed a minimum of 28 pounds of clamping force when roughing with the 1/4-inch end mill and 40 pounds during the face milling operation. To verify our keychains would not deform, we conducted a finite element analysis to find an approximate deformation of 3 thou at the 800-pound maximum clamping force, along with a passing von Mises stress. The deformation amount we found was insignificant and unnoticeable. Next, we'll take a look at the assembly drawing, the exploded view drawing, the fixture plate drawing, and notice the 3 datums, A, B, and C, along with the tight rail slot tolerance, which we will need to meet by accounting for tool wear. Then we have the standard parts drawing, a picture of the empty plate, a picture of the assembled plate with a loaded part, and lastly, an animation of the exploded view. Our operation planning document is presented above. We used a WCS of the bottom center of the stock and utilized the pre-made tooling library to design our cam, obtaining an approximate operating time of 22 minutes, which we'll conservatively call 40 minutes. This operation simulation shows contouring of the sides and indicating band, pocketing of the clamp relief, rail slot, and WCS, spot drilling, reaming, and tapping. Believe it or not, reaming before drilling will break a tool, so don't learn by doing that. Lastly, we engraved and chamfered. These pictures show our fixture post-operation. Everything went as planned, fits securely, and produces beautiful parts.
As for the economic feasibility of our fixture, the design proved to be more than reasonable. Costing analysis of the fixture can be seen here with the total estimated fixture tooling cost of about $1,600. If you notice, engineering costs are what make up the vast majority of this number. With these numbers being conservative estimates of our completed work, it can be said that this cost could in fact be far less if completed rapidly at the convenience of the buyer. Altogether though, the design is economically sound and repeatable with the ability to be produced multiple times for the tombstone. In conclusion, why should you go with us? Our fixture design is successful in many ways, meeting all design criteria. However, places it exceeds are with the load-unload time being well under a minute with simply using a torque wrench. Furthermore, our extremely ergonomic design includes features such as the pokey yoke dowel pin, easy to understand datum locating features, and the G54 probing bore. The design is cost-effective and easily machinable with carefully selected supplies that are available and as inexpensive as possible. No features are redundant. It is extremely user-friendly and allows for the creation of many parts effectively. Lastly, the overall goal of producing quality parts to spec is met and verified with great assurance.